Perfect. Thank you.
So what you're dealing with is from last week, hypothesis testing. There are assumptions that we have to make before we can perform a hypothesis test.
Mhm.
We're dealing with a mean. The big one is that either we must assume that the population is approximately normally distributed, or the sample size is sufficiently large. This is usually a sample size of at least 30. So if our sample size is 30 or more, we don't need to assume that the population is approximately normal. And of course, the other big one is that the sample is randomly selected from the population of interest. For proportion, it's a little bit more complicated. One is we have to assume that the number of successes is at least, depending on the textbook, at least 5 or 10. So that's the sample size times the proportion of success has to be greater than or equal to 10. And the minimum number of failures has to be at least 10. So it's the sample size times 1 minus p has to be greater than or equal to 10. Second, we have to assume that our sample isn't too large, that n is less than or equal to, again, it depends on the textbook, it's usually 5% or 10% of the population. So 0.05 is what this textbook uses, 5% of the total population. And again, the sample is randomly selected from the population of interest again. And so once those assumptions are met, we can go ahead and perform whatever hypothesis test we want to. For means, remember, if we know both population standard deviation, then it's a z-test. If we don't know both population standard deviations, then it's the t-test. But now with when we're testing two populations or two means, there is a third option, and that is matched samples or paired samples, where we have the data paired together and we take one from each pair and put one of them in each sample. Then what we're actually doing is we're actually only testing one set, which is equal to the differences of each pair. And so this is just going to be a regular t-test, where up here, this was a two sample t-test. And this, of course, up here was a two sample z-test. When we're dealing with, of course, comparing two populations. For the proportions, it's always a z-test. There'll be a two proportion z-test when we're comparing two populations there. Is that all you needed?
I have a question.
Yes.
Proportion, I thought I'd said hint in the page in the homework, and it said that it would be 4 assumptions that you would have to assume.
Let's see. I'm trying to remember if there's one that this textbook added in.
And one that I remember specifically is it said that it would have to, your X value would have to be your population would have to be at least 20 times larger than.
That's the little n is less than or equal to 0.05 times big N.
Oh, so that is what the 20 times larger is.
Yep.
Okay.
Let's see.
I have written it down. One is we have to have a simple random sample. 2 is the population is at least 20 times as large as the sample. 3, the individuals in the population are divided into two categories. And
Oh,
four,
yeah, that one right there is they're divided into two categories, and they're successful or failure. I mean, that's a given for any proportion, is there can only be two categories. So yeah, that would be the one that's missing from my list there. That one, most textbooks don't specifically state that one, simply because that's the definition of proportion. You either meet the condition or you don't. So you're divided into two groups.
okay,
So every item is either a success or a failure. Is all that is. So there's only two possible classifications for every item in the population. Any other questions on those?
Yeah, I had a quick question in regards to, I'm not sure if this is a stupid question or not, but in regards to when you reject and when you do not reject the null hypothesis, I'm still a little fuzzy as to when to do that. Are you able to kind of cover that one more time for us?
Yes, let's take a peek at that. So there's two methods to decide whether to reject the null hypothesis or fail to reject the null hypothesis. The first method is the critical value method. And the critical value method, the rejection rule depends on the alternative hypothesis, HA or H1. I believe this textbook uses H1, so I'm just going to leave it as H1. That's the alternative hypothesis. And the alternative, if the alternative hypothesis is that the mean is less than some value, I'm just going to put V in there for value, then the rejection rule, we will reject the null hypothesis if the test statistic is less than the critical value. So that critical value, that's the Z critical or T critical, depending on what type of test we're doing. If the alternative hypothesis that the mean is greater than a given value, then the rejection rule is that we will reject the null hypothesis if the test statistic is greater than, come on, a critical value. So it would be a positive Z critical or T critical. If we're greater than that, we would reject. And if the alternative hypothesis is not equal to, so U is not equal to a value, sometimes also written as the mean is greater than or less than a given value, then the rejection rule has two different critical values. They're the same number, just one positive, one negative. But the rejection rule becomes we'll reject HO if the test statistic is less than the negative critical value, or if the test statistic is greater than the positive critical value. So we direct on both tails. That's why that's called a two-tailed test. The other option, rather than using a critical value method, is to use a p-value method. And the p-value method, remember, alpha is set in the test. It's the level of significance. So if we're doing a 0.05 level of significance, that's alpha equals 0.05. And in this case, the rejection rule is always, we will reject the null hypothesis if the p-value is less than alpha. So that would be the 0.05 or 0.10 or 0.01, depending on the significance level requested in the test. Any other questions on hypothesis testing? Go ahead, Chris.
All right, I was just gonna say, so in regards to the p-value method, it's if the p-value is less than alpha for each of them, even if it's like greater than, less than, or
No matter what the hypotheses are, It's always less, the p-value has to be less than alpha. And
Okay.
that's the one that's most often used in conjunction with the TI-84 calculator,
Mm.
because the TI-84 gives you the test statistic, but it doesn't give you the critical value. It just gives you the p-value.
Yeah.
And so you can just compare that p-value to alpha. And if that p-value is less than alpha, you know you can reject the null hypothesis.
I think I was confusing the p-value method with the critical value method and swapping them too. So anyway,
And
thank
that's
you.
very common because the p-value method is always simply, less than. And that's one of the reasons it's easier than the other, is because you're only looking for it to be less than alpha. Whereas the critical value method, it changes depending on what your hypotheses are.
That really helps. Thank you so much.
You bet. Any other questions?
Yes, something that trips me up about this is, so the statement that comes after you figure out if it's a whether you reject it or not is it says, does this statement, is this enough or is this not enough evidence to determine if this I think you know what I'm trying to get at. I don't want to confuse
No.
anyone by going further, but
So it all depends on what the hypotheses state, but in general, if you reject HO, the null hypothesis, that means there is enough evidence to go against, if you want to put it that way, or to refute that null hypothesis, whatever the null hypothesis says. If you fail to reject HO, that means there is not sufficient evidence to go against whatever the null hypothesis is stating. It doesn't mean we have to accept it. It just means we don't have enough evidence to reject it and to go against it at this time.
okay, thank you. That makes so much more sense. Appreciate it.
You bet. Okay, so let's get into our new material here. First, a couple of notes. One is final exam should be available starting next Monday, October 31st. Starting on Halloween is a great omen for it, but it is what it is. And of course, must be finished by November, let's see, 5th, I believe, is it? Yes, November 5th. It might say November 6th is Sunday, but most proctors aren't going to be available on Sundays. So try to have it done by November 5th. Let me just do a quick little peek into Alex here to make sure that Alex is what Alex is set at. If it'll let me. My internet has been working really slow the last couple of weeks, so I apologize for that. I just wanted to check to see if Alex was set to Sunday, so in case it happens, if you could get to it on Sunday, we'll get that to come up before we're done here.
I had a quick question. Is the final exam, it is not cumulative, correct? It's just from the week 6, is that correct?
It is mostly week 6 through week 11. I'd say about 80% of it is on that. And then there's about 20% that is cumulative, only because you have to know those basic topics to be able to still understand the more advanced stuff. So there might be 1 or 2 basic probability questions or a type of sample question, things like that. Nothing real rigorous, just some of the things you have to know in order to be able to understand what's going on in the week 6 through 11. So there might be maybe a basic binomial probability might be on there, or a simple probability, or some basic vocabulary. by vocabulary, knowing the and the symbols. So you know the difference between the symbol for a population mean and a sample mean, and population standard deviation and sample standard deviation, and those things. It might not be asked directly, but those are things you'll have to be able to understand some of the questions. But yeah, it is pretty much focused on week 6 through 11.
Awesome, thanks.
So there is a 3-hour time limit. Remember, again, there is a note sheet that is attached in ALEKS. It has formulas and calculator commands in it. And you get that by going into ALEKS, and I'm going into settings, and I don't know why this isn't loading for me. Here it's loading. Okay, good. I'm going to go out of here and I'm going to switch screens. So in ALEKS, once you sign in, log into our class, of course. You'll want to do this in front of your proctor. If you're doing ProctorU, once you get connected with them, say, hey, I'm going to download my note sheet now. You're just going to click right here on Course Tools, and then go to Resources. If you go into Resources, you'll see there's the final exam formulas. You got to use the final exam, not the midterm exam. Download the final exam formulas. When you click on that folder, you'll see there's actually 3 things you can use. One is a formula card. That's some of the formulas from out of the textbook. Next is the statistical tables. That's your Z table, T table, if those are things you like to use. If you're using the TI-84, you shouldn't need those tables. And then finally, the final exam formulas. This is formulas, calculator commands for how to use the calculator, which commands on the calculator do what for different types of problems. So I would suggest you go in and download those now and look them over and have them ready. It always depends on, every now and then you'll run into a proctor that says you got to have them printed off and have a hard copy of them. So I would suggest you have them printed off and bring them with you, or have them next to you when you go to take the exam. And if the proctor says you have to toss those aside and download them again, that's great. That's what it's intended to be. But every now and then one proctor will say, nope, you got to have them printed off ahead of time. So I just caution, print them off and have a hard copy with you, just in case something like that happens. Also, there's occasionally the issue that memory issues where a computer can't handle having those documents open and dealing with ProctorU at the same time. Just want to double check here to see what the due date is set on the final exam. So it is set for the 5th. So be prepared for that. If you aren't able to get it taken by the 5th, ALEKS will cut you off. If you have issues, let me know and we'll try to work with you, but we really do need those done by the 5th. My grade deadline is Tuesday, the 8th. So if we don't have them done on time, usually that results in an incomplete grade. So we don't want to deal with incompletes. That can cause all sorts of problems getting registered for classes for next term for you. Also, the final exam practice assignment should be available now. Once you've completed that, if there's any issues, you should be able to complete it, then go back in and look at it as much as you want to. If there's any issues with that, please let me know, and I will go in and change settings so that you can go back in and review it as many times as you want to prepare for the exam. I think the time limit has been lifted on that. We used to have a 3-hour time limit so that the practice was the same conditions as the exam, but I believe that's been lifted now. But even if that time limit is not on there, I do highly suggest that you time yourself The practice is designed to be very similar to the exam in length and number of questions. They won't necessarily be the same questions, but it'll be the same questions on the same topics. And so if you can complete the practice exam in the 3-hour time limit, you should be ready to go to do the regular exam in the 3-hour time limit. So try to hold yourself as close to the exam conditions as you can, at least the first time you go through the practice exam, just to see how you would do on the final. That's a pretty good predictor. Then if you need to go back and study stuff, you can do that then from that exam. Okay, so our last topic. This week, we are finishing up our new material. And some things, if you're looking in Canvas or in my videos, things that are no longer in the course are chi-squared tests. So I know my videos still have, the videos I made still have chi-squared tests in them. Please feel free to skip over that portion. That's not part of the course anymore. And if anything's in Canvas that still includes chi-squared tests, that was removed actually a semester ago. So be aware you can skip over any of that. All that this week is now is a linear regression. And so what linear regression is it is simply an attempt to link and create a numerical relationship between two sets of data. So we're looking at bivariate data, and we are looking for some sort of relationship that links the two sets. And the key word here is something called correlation. And correlation is just a measure of the strength of relationship between those two variables. And by strength of relationship, one of the ways that's defined is ability to use to predict. In other words, if I know one of the values, can I use that to somewhat reliably predict the value of the other variable? And so we're looking at modeling and linear regression, which is all we're doing in this course. We're not doing any multiple regression or quadratic regression or anything like that. Simply, we're looking to find the best linear equation, to summarize that relationship, or that correlation. And then the equation is what we're going to use to predict. And so basically we're starting out with a scatter plot. And a scatter plot is simply a graph that displays two variables, one on the horizontal axis and the other on the vertical axis. Used to call these the x-axis and the y-axis. We don't use that terminology anymore. It's sometimes called the predictor and the reactionary axis. Anyway, it's the same concept. We have our scatter plot, and we might be looking at relating high school GPA with ACT test score. And you would think it would make sense that the higher their GPA is in high school, the higher their ACT test score is. So if they had a high GPA, they had a high test score. If they had a low GPA, probably had a lower test score. Now, there might be somebody that was really intelligent that just didn't work very hard in high school that had a low GPA, but a fairly good ACT test score. And the other side might be true. There might be people whose parents helped them with all their homework or had tutors help them with all their homework and had a pretty good GPA, or maybe they just struggle with tests. They have test anxiety. They had a really good GPA and a fairly low test score. But in general, we would expect those values to be pretty close to a line down the middle here. Whereas the GPA gets bigger, the test score gets larger. Now, I mentioned that word correlation. And correlation is simply a numerical assessment of the strength of the relationship between these two variables. Again, we could call them X and Y, we could call them predictor and reaction, whatever. Now, there is a little bit of a link between correlation and slope, but I hesitate to say that because the link is very easy to confuse. A positive correlation equals an increasing line. In other words, a positive slope. But it does not say anything about how steep that slope is. A negative correlation equals a decreasing line. In other words, a negative slope. But again, it doesn't say anything about how steep or shallow that slope is at all. If we have close to 0, that means points are nowhere near a line, or no relationship between those two values, two variables. A strong correlation will be, notice I'm not putting equals here, it's either close to a -1 or close to a +1. So the most common correlation is something called the Pearson correlation coefficient. And actually this textbook calls it the Pearson sample correlation coefficient. And the Pearson sample correlation coefficient is between -1 and +1, where -1 equals a perfect negative correlation. A +1 is a perfect positive correlation. And of course, 0 is no correlation, no relationship at all. Or at least no numerical relationship between those variables at all. So what does that mean? Well, if I'm going to graph this, let's go to the new page. So if here's my axes, and I might have a row of dots like that. Well, as I draw a line through those, they're almost perfectly on the line. The fact that they're almost perfectly on the line means this is going to have a correlation close to 1 or -1. That line has a positive slope. So that means that correlation is basically +1 or really, really close to it. The other side is I might have points that go like this. Well, there's a line, they're almost, again, almost perfectly on the line or perfectly on the line. And that would be a correlation of about -1. Now the positive simply means that there's a positive slope. The 1 tells me they're pretty much on a perfect line. It doesn't say how steep the slope is, because let's go back here to this first graph. I could have points that are like this. Those are also pretty much perfectly on a line. That would also have a correlation of +1. Even though the green line has a much steeper slope and the purple line is a much shallower slope, what matters is their positive slope. That's why it's a positive number. And the points are perfectly on the line. That's why it's a 1, a +1. The same would be true over here. I could have points. Oops, those are lines, which is the point. If I put my line through those, again, they're perfectly on the line. Even though that line is a steeper negative slope, it's still a correlation of -1 because the points are exactly on the line. And it's a negative slope. So the correlation doesn't say anything about the steepness of the line. It just says whether it's a positive or negative slope, and then how close the points are to being perfectly on the line. So the other side of that would be something like this. Well, let's do that. Where there really is no line that would go through those points. I could draw any line through those points and it'd be just as good as any other line I drew. There is zero correlation there because they're not linear. There's no line that describes those points well. And then of course, most lines are somewhere between 0 and +1 or 0 and -1. And they're not perfect like these examples up here. So let's look at calculating that Pearson correlation coefficient. So there are a couple of formulas. Typically, it's either a little r or a capital R. I've been taught to use little r. So the little symbol little r means Pearson correlation coefficient. And it is going to be the sum. I'm just going to write this out. So sum of the z-score of the x value times the z-score of the y value for each of the points divided by n-1. So what does this mean? Well, let's go to a set of data and actually calculate this out. So here I have a set of data that represents those 6 high school students I have. I have their high school GPA and I did not get their ACT score, but I'm just going to put an ACT score on here. Let's say this student had an ACT score of 27. Let's do 26. This one had 29. Let's put this one 3.8. Let's put them at, let me try this again. So 26, let's do 24, 29, 25, 31, and let's put this one at 27. So those are my high school GPAs and my ACT scores for each of my students. Now notice the formula was z-score. So remember, to find a z-score, we have to know the mean. So we're going to find the mean for each of these. So the mean high school GPA is 3.45. The mean ACT score is 27. Then we need to find the standard deviation for each. And these are samples. So the sample standard deviation there is 0.39875. This is 2.60. So then the Z for the GPA is going to be this value. Oops, sorry, put parentheses in there. Their actual score minus the mean. I'm going to put a $sign in there, so this will float down with me, divided by that standard deviation. So I'm going to put a $sign in there. Then I just cut. Now notice this one here, 3.4 is slightly less than the mean, so it's a small negative number. 3.8 here is quite a bit more than the mean, so it's a positive z-score. 4 is pretty high, so that's a really big positive z-score. 2.9 was really low, that's a really big negative z-score. And let's do our z-score for the ACTs. That's going to be this. So again, I gotta do my parentheses. This minus this mean. Again, I'm gonna put in my $sign so it'll float down. Divided by this standard deviation. And if we copy those down, we get the z-scores for each of the ACT scores. So now I'm going to multiply those. My z GPA times my z ACT. So that equals this times this. And we add those up. We find the sum. And then we divide that by n minus 1. So our Pearson correlation coefficient equals this here divided by 6 is n, 6 minus 1. Give us 0.92325. That is our correlation coefficient. Now that is saying 0.9 is close to a 1. So that's saying that yes, it's positive. So that is saying as the GPA gets higher, the ACT score is going to get higher. And 0.92 is a pretty high correlation. Now that's saying there's a pretty strong relationship between those variables. Now there is an alternative formula for this, which is a lot longer. But you'll see in a little bit what the benefits of this formula are when we go to calculate other values in our regression relationship. So this formula is that R equals, I'm going to switch you over here, the sum of the X times Y values minus the sum of the X's times the sum of the Y's divided by N, all over the square root of the sum of the X squareds minus the sum of the X's squared over N times the square root of the sum of the Y squareds minus the sum of the Y's squared over N. Let me show you what this means. Let's get back to Excel here. I'm going to copy these 3 columns to a new sheet. So there's my GPA and ACT score again. So remember the values we needed. One were the sum of the X's. So the sum of the X's, I'm just going to add these values up. The other was the sum of the Y's. So I'm just going to add up the Y's. Here's the sum of all the ACT scores. Now I'm going to put the value squared in here. So that's just going to be this value squared. 20.7 squared is 428. And do the same over here. That's going to be a pretty large number. Next, I want to square each. So GPA squared is going to be just this value squared. And I want to find the sum of those. And then I want to do the ACT squared. So I square each of those and find the sum of those. Then I want to multiply each of them together. So GPA times ACT. So GPA times ACT for each. And find the sum of those. And so the formula was R equals, this is going to take a little bit of doing here. So the sum of the XY's, that's this value, darn it, equals the sum of the XY's, that's this value, minus the sum of the X's times the sum of the Y's divided by N. So I'm just put divided by 6. That's my numerator. And on bottom, I have the square root of the sum of the X's squared, or sum of the X squareds. That's this value, minus the sum of the X's squared. That's actually this one here, divided by n, so divided by 6, close that, times the square root of the sum of the y's, the y squareds, that's this one, minus the sum of the y's squared, that's this one, divided by 6, close and close. And then we get the same correlation, 0.92325. Now you might be looking and saying, well, this was a lot easier to do the z-scores and go with that, which I agree, that was a lot easier. But when we look at calculating our b value, it's going to come right off of this. So anyway, we found an alternative way of finding our correlation coefficient. And that'll be useful in just a couple minutes when we look at calculating our parameters of our equations. So a quick review then. So that's, again, that's saying that correlation is saying how closely our variables are related. Now we should stress correlation is not causation. Just because there's a strong correlation does not mean that one variable causes the other to change. There could be a third variable that affects both of them. It should be affects, not effects. For example, you might say that the longer the day is, the more times a cricket chirps during an hour. This is actually a study that has been done. That longer days equals crickets chirp more times per hour. It actually happens. Well, the longer day does not cause, even though there's a very strong correlation between the length of daylight in a day and the number of times a cricket chirps in an hour, the length of daylight in the day does not cause the cricket to chirp more. What actually causes the cricket to chirp more is the season, the temperature of the air during the day. Well, the season causes the temperature to be different, and the season causes the day to be longer or shorter. So it's the seasons of the year that cause both of those things to change. Neither one of them, the length of the day or the number of times a cricket chirps, neither one of them causes the other, but they're correlated because they have a common cause that changes both of them, that causes both of them to have those desired effects. So be very careful with that to ask if it asks if there's evidence to say that this causes that. Be very careful how you draw that conclusion. It can be used to show causation, but it doesn't necessarily mean, just because a strong correlation does not necessarily mean there is causation. So be careful. A review of linear equations. So linear equation takes the form y equals ax plus b, where a is the slope of the line and b is a y-intercept. It's where the line crosses the y-axis, or the value of y when x equals 0, if you want to think of it that way. And actually, or depending on the textbook you're looking, could take the form y equals bx plus a, where it means the same thing, just the b and the a are switching places. B is the slope and a is the y-intercept. So you got to be careful to look at how your textbook is describing it. This textbook uses the second form, y equals bx plus a, where b is the slope. So to find the slope, of the regression equation, in this case for b, b is equal to the sum of the x times y's minus the the sum of the x's times the sum of the y's over n. Notice that looks very similar to the top part of this formula here. It's exactly the same. Divided by the sum of the x squareds minus the sum of the x's squared over n. Again, notice that's that's a little under half of the bottom of that formula. So if you have all that information for calculating that, we can find B very quickly. So that's why some people prefer to use that formula for to find R, because now that we have that, we can find B rather quickly. It's just going to equal that same numerator, which is the xy's, which is right here, minus the sum of the x's times the sum of the y's divided by n, which is 6, all divided by the sum of the x squareds, which is this, minus the sum of the x's squared divided by 6. And there it is. That is the slope of our regression equation. Then to find A, that's B, to find A, we have to have x bar, which is the average value of x, and y bar, which is the average value of y. Let me erase this and try that again. X bar, good. And if that is the case, then A is equal to y bar minus B times x bar. So again, let's go back to our Excel file here. We have the mean x value and the mean y value. So we can find A as the mean y value minus B times the mean x value. So there's A, 6.16. So my regression equation is y equals 6.16981 plus 6.03774x. Or you might say y equals 6.03774x plus 6.16981. Doesn't matter what order you put them in, but notice the 6.03774 is with x, and the 6.16 is by itself. The B value is the slope that multiplies x, and the A value is the y-intercept. That's the one that's always by itself. Both of them should be acceptable in ALEKS. If ALEKS does not take one form or the other, let me know. Sometimes what ALEKS will do is it will, let me get back here so I can draw it out, is it'll say, A equals, there's a box there, and B equals, and then there's a box there. Or it might say Y equals a box, X plus another box, and you have to fill the values into those boxes. So you just have to make sure the slope is the one that goes with the X. So you have to make sure you get them in the right spot is all. Yeah, you have to make sure you get them in the right spot. Well, that's a lot of work. Excel helped with that calculation, and we only had 6 data points. If we had, 20 or 30 data points, even with Excel, that would have taken a while, but it would have really been a bear doing it by hand. So let's go to the calculator. Now I'm going to copy and paste some of my values here from Excel. I guess I can't. I'm going to write them down though quick, just because I don't have them. So 26, 24, 29, 25, 31, and 27. So let's go into the calculator and do this the easy way. So in the calculator, we're going to go to Stat. In the Edit menu, we're going to select Edit, which is going to take us to our list. Now, again, we want to clear out our list. So you go up and highlight the top of the list, hit Clear and Enter to clear out the whole list. I want my X value in L1. In this case, that will be the high school GPA. So 3.4, 3.2, 3.8, 2.9, 4.0, and 3.4 are the high school GPAs. Now we go over to list 2 and we're going to put in the ACT score. So 26, 24, 29, 25, 31, and 27. There's my ACT scores. So I'll do second and quit to get out of here. I'm going to go to Stat and I'm going to go to Calculate. And now there are two different linear regressions. There's linear regression AX plus B. Well, remember, we said we were using A plus BX or BX plus A. So if we go down a little further, we find that option, linear regression, A plus BX. That's the one we want to match up best with our textbook. X is in list 1, Y is in list 2. Frequency, we always leave that alone, and we store a regression equation, we leave that blank. We just go to calculate. And notice there it gives us the regression equation. A is 6.16981, which is what we found. B, the slope, is 6.03774, exactly what we found. Now, your calculator might not give the R squared and the R value down here. Let me show you why, and let me show you how to fix that. So if you go to catalog again, we're going to go all the way down here to diagnostics. So right now, my calculator has diagnostics turned on. Unfortunately, most calculators have diagnostics off as their preset value. So I'm going to show you what that looks like. I selected diagnostic off, and I have to hit enter again to activate it. Now, if I do my stat calc, and I go down to linreg A plus BX, you'll notice it gives me the equation A and B, but it does not give me R or R squared down here. It just gives me the equation, which is what your calculator most likely is giving you at this point. So in order to get it to give me that R, that correlation coefficient R, and then we'll explain what R squared is later, we have to turn diagnostics on. So today you do second catalog, and you just arrow down to diagnostics. Takes a little while. So there's diagnostics off. I want diagnostics on. So I select that, then I hit enter again to activate it. You got to make sure it says done there to be activated. Then we go back stats, calculate, linreg AX plus B, calculate, and now it gives us those values. So the R is the 0.92325, which is what we had calculated for our correlation coefficient before. R squared, 0.8524 here, is a value I want to talk about. So R squared is 0.8524. Well, R squared most of the time is given as a capital R, by the way. Capital R squared. I mean, it literally is the correlation coefficient squared. The difference, of course, is R squared, capital R2 is for R squared, will always be positive, and it represents a percent. And what it actually represents is what we call the coefficient of determination. And what it represents is the percent of the variation in the y variable that is explained by the regression relationship. So what this is saying is 0.8524. That's saying about 85% of all the variation in the ACT scores is accounted for by the GPA. The other 15% comes from other factors. So notice it's slightly different than our correlation coefficient. Our correlation coefficient was did I jot it down here? I did not put it down here. That 0.95, whatever it was. I'll go to my Excel spreadsheet and grab it. 0.92325. R squared, if I square that number, 0.92325, notice I get 0.8524, which is what that value was. So let's talk about what we used these before. We got just a few minutes left. We can use the regression equation to predict. For example, no student had a 3.5 GPA in my list, but we can predict based on that equation. There's somebody in the chat. Let me take a peek. When I use the LinReg AX plus B, the calculator does not show me where to enter the information like it does. Okay, so your calculator, I'm trying to think, Ricardo, if you have if you don't have the stat wizard, it should show you the same menu when you enter that. Just try to do L1, L2 and see what that does. If that doesn't do it, then I'm not sure what your calculator does. It should show you some sort of a menu asking for the X list and the Y list. Okay, so there you got to press enter a second time. Yep. Okay. So anyway, let's look at our equation here. I'm just going to paste it in here. So we're going to predict for a 3.5 GPA. So we're going to do y equals 6.16981 plus 6.03774 times, we put, instead of X, we put in 3.5. So let's put that in the calculator. There we go. And so you can see my numbers. So 6.16981 plus 6.03774 times 3.5. It gives me 27.3. So 27.30 is what it is predicting would be the ACT score for somebody. If they had a GPA of 3.5. Well, sometimes we want to predict with values that we do have, and this creates something called a residual. So a residual is the difference between the actual Y value and the predicted Y value. So for example, let's look at a 3.4 GPA. So 3.4 GPA had an actual ACT of 27. let's predict using the equation. So that ACT score would be 6.16981 plus 6.03774 times 3.4. Let's see what that predicts on our calculator. It looks like you're getting that figured out. Good. So on the calculator, we're going to put in 6.16981 plus 6.03774 times the 3.4 GPA gives us 26.70 is that predicted ACT score. Well, the residual is the difference between that predicted 26.70 and the actual value of 27. So it's a negative 0.30 residual. That's just saying our predicted value was 0.3 of a point below the actual ACT score. And the whole point of this linear regression, this least squares linear regression it is called, is to minimize those residuals. So this is the regression equation model that will give the smallest total residuals for our values. But when you're asked for residuals, that's what it's asking for, is simply that. Find the predicted value and compare it to the actual value for each X or input value in this relationship. So that is it for our material for this week. I feel like there's a lot of stuff there. Anybody have any questions?
Yes. Can you summarize the significance of the R value and the R2 again
Okay,
with the
so
residual and how that goes forward? I forget the meaning of each of those terms.
the R value is the correlation coefficient. And the correlation coefficient is between -1 and +1, where -1 is a strong negative relationship, which means when X gets larger, Y gets smaller. The closer it is to -1, it's more predictable. 0 would be no relationship. That the changes in X do not affect the changes in Y at all. And a +1 is a strong positive relationship, which means X gets larger, Y also gets larger. And again, in a very predictable manner. R squared is the coefficient of determination. And this is always between 0 and 1. And it is the percent of the variation in Y that is related to or caused by, I shouldn't say caused by, but is connected to the changes in X and the regression relationship. So basically it's saying, if we have a R of a negative 0.9, that is saying that there's a strong relationship, strong correlation, but X gets bigger, Y gets smaller. If R is negative 0.9, then R squared would be 0.81, because negative 0.9 squared would be 0.81. That is saying 81% of the changes in the Y variable are because of the regression relationship. Now, residuals are something totally different. Residuals are the difference between the actual data value for Y and the Y value predicted by the X value and the regression equation. So if we have a student with a GPA of 3.4 and an ACT score of 27, this 27 is the actual value, the actual data value. If we use the equation with 3.4 in it for X, we get an ACT score of 26.7, which is close to the actual ACT score, but not quite. The residual is the predicted 26.7 minus the actual of 27. So it's a negative 0.3 residual, or 0.3 residual. So that's the difference between what the regression relationship predicts and what reality actually produced. I see some stuff in the chat. Let me stop sharing and I'll get to the chat. So the R squared is the percent that is predicted. So the R and the R squared are not connected to the residuals. I will say the bigger the residuals are, the smaller your R value or your R squared value will be, but there isn't any way to really connect them. Any other questions? Okay, I'm sure more will come up as the week goes on. So if anything comes up, please let me know and I'll get back to you as soon as I can. Otherwise, next week, I will be here. I should clarify what would happen next, what will happen next week. So I will be in here to answer specific questions. I'm not supposed to, it will not be a test review session. The test review session, the SLC is doing a test review. And I believe that's being held Saturday, the, was it 29th? Will be that session. I'm not supposed to do my own review because I don't want to step on that. The people that do that review are given the information that the department wants them to go over and review. So I'm not supposed to interfere with that, but I will answer questions from the review. So if there was something in the review that they went over and you don't understand, if you bring those examples in with you, I can go over those a little bit with you to explain how they were getting the answers they were. Or if you have specific questions from the Alex final test review and you want me to go over them, I will go over that. Otherwise, there will not be any prepared lecture for next week. So if you're not in here, you're not going to be missing much. It's just your last chance to ask questions is all that's going to be.
For the SLC review, I'm assuming that's only in person, correct?
They do have it online. You can log in and view it through Zoom. And they also will record it so that you can download the recording and watch it that way as well.
Okay, awesome. Thanks.
Yeah, just go to the SLC website and they should have that posted. And if it's in a time that you can't attend, just send them a message telling them that you can't attend, but you would like the link to the recording sent to you. And they usually are pretty good at sending you the recording link so you can watch it yourself.
Awesome. Thanks.
You bet. Okay, so with that, I will